Example of using the rational root theorem and a few other theorems to factor out or find the roots of this function f of x. So we're going to start off like normal and do the a sub 0 over a sub n part. And a sub 0 in this case is 15. Remember, we don't care that it's positive or negative. We'll take care of that later. And then the a sub n is 2. So when we do the factors at the top and the bottom, we're going to get 1, 3, 5, and 15 for the 15. And for the 2, we're going to get a 1 and a 2. And then finding all the factors over each other, we're going to get 1, 3, 5, and 15. And 1 half, 3 halves, 5 halves, and hopefully we won't get to it, 15 halves. Alright, so the coefficients we're going to be taking off our polynomial are 2, negative 7, positive 3, positive 17, negative 15. And there's no powers missing, so we don't have any zeros. And then just start synthetically dividing, and I'm going to start with positive 1. So drop a 2, that'll give us 2, negative 5, negative 5 plus 3 is negative 2, that'll be negative 2 plus 17 is 15, that'll be 15 minus 15, which is 0, and we got lucky that we found 1 right off the bat. So x is equal to 1 is one of the roots, x minus 1 is one of the factors. Because we ended up with 0, we're going to have to, well, we don't have to, but to make life a lot easier, I'm just going to reduce my problem down to its other factor, which is 2, negative 5, negative 2, and 15. The last 4 numbers before that 0. Alright, and then start synthetically dividing. I'm going to try one more time because it has a possibility of being a root of multiplicity. So drop the 2, that'll give you negative 3, that'll give you negative 5, that'll give you 10. So it's not a root, but we just got rid of the possibility that it was a root of multiplicity. Alright, and then work up to the next number, which is 3. Drop the 2, that'll give you 6, that'll give you 1, that'll give you 3, that'll give you 1, that'll give you 3, and that'll give you 18. What's important about this line is it's all positives as answers, the 2, the 1, the 1, and the 18. So here we can say that x equals 3 is a upper bound. That means we don't have to go any further than x equals 3 looking for possible roots. They're not going to work. So we're done with the positive numbers, so let's go to the negative numbers. Let's try negative 1. Drop the 2, negative 7, positive 7, positive 5, negative 5, and another 10. Well, that doesn't tell me much. Alright, next number would be negative 3. Drop the 2. This would be negative 6, negative 11, positive 33, positive 31, negative 93. That's going to be some negative number. I'm not even concerned what it is. But one thing did happen. It went from a positive at this 10 to a negative at this, whatever this negative number is. But because the sign changed by the intermediate value theorem, there must be some answer between negative 1 and negative 3. So all I have to do is pick out which one of these values is between negative 1 and negative 3. Well, the only one I see here is 3 halves and 5 halves, being 2.5. Both of them, of course, negative. So let's try the first one, the 3 halves, and see what happens. So negative 3 halves, bring down the 2. Multiply those two together, you get negative 3, that'll give you negative 8. Multiply these two together, you're going to get 2 goes into 8, 4, 4 times 3 is 12, it'll be positive, and 12 minus 2 is 10. Then half of 10 is 5, and 5 times negative 3 is negative 15, and that'll give us our 0. So that little trick of the intermediate value theorem gave us a clue to use negative 3 halves, and it actually worked. So we're going to get x equals negative 3 halves is our root. As a factor, it would be x plus 3 halves. Alright, Now we're down to three numbers. And once you get down to three numbers, you're dealing with a quadratic. So I'm going to treat it like a quadratic. Use this little space here. And we're dealing with 2x squared minus 8x plus 10. And since we're looking for roots, I'm going to set it equal to 0 and solve. Well, each of them have a factor of 2, so I can divide it out. So you're going to get x squared minus 8, not minus 8, minus 4x plus 5. Now, are there any factors of 5 that add up to 4? Well, I can't think of them. Not add up to 4. I know they subtract up to 4, but they definitely don't add. So I'm going to use the quadratic formula. And it starts off, of course, with the b squared minus 4ac. I like doing the discriminant first. And let's see, this becomes b is negative 4, a is positive 1, c is positive 5. This is 16 minus 20. Oops. And 16 minus 20 is negative 4. So we're going to have imaginary roots here. Alright, let's finish it off. So we're going to get x is equal to negative b, b is negative 4, plus or minus the square root of this negative 4 right here, our answer to the discriminant, all over 2 times a, better known as 2. So my other two answers are going to be 4 plus or minus 2i over 2, better known as 2 plus or minus I. So my four answers would be x is equal to 1 from over here, x is equal to negative 3 halves, and these two answers, 2 plus I and 2 minus I. And since the degree of this polynomial is 4, we have found every single one of the answers.